A Lagrange point is a point in space where the gravitational forces of two large bodies such as the Earth and the Sun or the Earth and the Moon equal the centrifugal force experienced by a considerably smaller third body. The forces interact to generate a point of equilibrium where a spacecraft can park and conduct observations. These points are named after Joseph-Louis Lagrange, an 18th century mathematician who wrote about them in 1772 in a paper called The Three-Body Problem. They are also known as liberation points and Lagrange points. There are 5 Lagrange points around major bodies like planets and stars. 3 of them are positioned along the line that connects the two large bodies. For example, in the Sun-Earth system, the first point, L1, lies between the Earth and the Sun at approximately 1 million miles from the Earth. L1 has a direct view of the Sun and is currently occupied by the Solar and Heliospheric Observatory and the Deep Space Climate Observatory. L2 is also a 1 million miles away from the Earth but in the opposite direction of the Sun. A spacecraft can have a clear view of outer space at this point with the Earth, Moon and Sun behind it. The Wilkinson Microwave Anisotropy Probe WMAP of NASA is currently at this point, L2, monitoring cosmic background radiation left over from the Big Bang. The James Webb Space Telescope has recently reached this point. Meanwhile, the third Lagrange point, L3, is located behind the Sun on the other side of the Earth's orbit. Science is yet to find a use for this point, but the science fiction has. L1, L2 and L3 are unstable points with a precarious balance. Like a barely balanced cart on a steep hill, a spaceship at L3 drifting toward or away from the Earth would dive irreversibly toward the Sun or the Earth. Spacecraft must make minor changes to maintain their orbits. However, points L4 and L5 are stable like a ball in a huge bowl. These points are located along Earth's orbit at 60 degrees ahead and behind Earth, forming the apex of two equilateral triangles with the large masses. For example, Earth and the Sun as their vertices. As we all know, the Earth orbits the Sun once a year. L2 exactly lined up with both the Sun and the Earth. The combined gravity of the two large bodies tugging in the same direction offers a spacecraft an extra boost of energy, locking it into perfect unison with the Earth's yearly orbit. So why is L2 the most preferred location for the most advanced space telescopes? It's an excellent point to view the greater universe. A spacecraft would not have to perform regular orbits around the Earth, which would result in passing in and out of the Earth's shadow and causing it to heat up and cool down, distorting its view. L2 provides a much more stable viewpoint because it is free of this constraint and far away from the heat emitted by the Earth. Also, one advantage of L2 when compared to Earth orbit is that it allows scientists to have an enormous bandwidth because over conventional K-band radio, the communication speeds are very high. Another advantage is that scientists can radiate the heat away. The L2 point of the Earth-Sun system is home for the WMAP spacecraft, Planck, Herschel, Plato, and the recently launched James Webb Space Telescope. L2 is great for astronomy since a spacecraft is close enough to communicate with Earth easily, can maintain the Sun, Earth and Moon behind the spacecraft for solar power, and provide a clear view of outer space for the telescopes with sufficient shielding. The number of spacecrafts at the L2 point instantly indicates that things could get crowded. We all know there's a lot of space out there, but these spacecrafts are situated in a stable periodic orbits around the L2 point itself. The Lagrange points won't begin to get too crowded until many probes move to these areas. As we all know, space is pretty big, and the Lagrange points are not single points, but 3D expanses that cover quite a large dynamic region. So, L2 is not crowded, and at the moment, there's still plenty room for other spacecrafts. Thanks for watching and see you in the next one.